warm welcome to my dear students. Children, today we are going to discuss about the Boolean algebra and the laws related to it. As you all know that, what do you mean by Boolean? Boolean is nothing but the two numbers 0 and 1. That means binary digits are known as Boolean numbers. So we will be dealing with the Boolean algebra in this video. So, Boolean algebra is introduced by English mathematician in 1854, and the English mathematician name is George Boole. So, Boolean algebra revolves around the binary numbers, that means 1 and 0, and we will also discuss now that what are the various gates, AND gate, OR gate, NOR gate, and various theorems related to the Boolean algebra. Now, first we'll deal with the Boolean functions. When it's come to the Boolean functions, we have three types of operations, three types of mathematical operations that can be performed on the Boolean numbers. That means 0 and 1. So, first one is AND. AND is nothing but your multiplication, or means addition, and not means simply the flipping of the digits. So just see in the first diagram, that is in A part, just see it, we have the two possible combinations x and y, and the possible combinations in zeros and 1 is 0 0 0 1 1 0 and 1 1. When it comes to the AND operation, we are simply multiplying it. So 0 becomes 0, 0 into 0, 0 into 1 is 0, 1 into 0 is 0, and 1 into 1 again is 1. Then next we have AND operation, OR operation. OR operation means logical addition. Logical additions, if we add 0 0, we have 0. If we have 0 1, then we have 1. 1 plus 0 is 1, and 1 plus 1 is 10. But in the truth table, we will write it as a 1. So these all basic functions we will be discussing here. AND is multiplication, OR is addition, and NOT is nothing but the flipping of your digits. So basic functions, here we have certain truth table written over here, we have already discussed in the class. Now comes to the Boolean operations and its symbols. So logical operation OR, so it is represented by the symbol given above. This is known as a logical OR operation, that means Boolean addition. Boolean multiplication, that means the symbol is similar to the D, and what we do in this, we will simply add on, we will multiply the numbers. Now comes the basic Boolean laws and Boolean identities of the basic Boolean algebra. So first we have that the properties of zeros and 1, right? So if I am saying the first identity, say that x plus 0 is always equal to x, and x into 1 is equal to x. X plus 1 is 1, and x into 0 is 0. X plus x is x, and x into x is always equal to x. Then we have, this is complementary law. X plus x bar is equal to 1, and x into x bar is equal to 0. Ninth one is the involution law. That means if we double flip the number, we will have the same number. Then we have commutative law. X plus y is equal to y plus x. And associative law, that means we are exchanging the brackets. And then 14th and 15th is the various version of the distributive law. That means if we write x bracket y plus z, so we can write in the way xy plus xz. Similarly, x plus yz can be written as x plus y and x plus z. The 16th one and the 17th one is the De Morgan's theorem. De Morgan's theorem states that if we have an addition of any two numbers and we complement them, so the addition becomes multiplication but complement will remain there. So this is the laws of Boolean algebra. a plus b is equal to b plus a, and in the other version it is a dot b is equal to b dot a. Associative law, so we can write like this, that a plus b plus c can be written as bracket can be interchanged a plus b plus c. Similarly, a bracket b c bracket is equal to a b bracket c. It is one and the same. Distributive law states that I can distribute the number between the brackets, that becomes a bracket b plus c bracket becomes ab plus ac. So this is the properties of zeros in 1. A plus 0 is always equal to 0 in Boolean algebra, and a plus 1 is also equal to 1. A into 0 is 0 and a into 1 is 1. These are again the properties of zeros in 1, which is written like this, that a into a bar is equal to 0. So this is the De Morgan's theorem. Here we have also verified it with using the truth table. So another version of the De Morgan's theorem. So a plus a into b complete bar will become a bar plus b bar. That means in De Morgan's theorem we have to change the operation. If we are doing the multiplication, it becomes addition, and if we are doing the addition, it becomes the multiplication. I hope you like the video. In any if you have any queries or any problems related to the same, so you can discuss in the class. Thank you.